Okay, we have our next question here. This is 3 sine x minus 4 is equal to 5 sine x minus 3. So we have 4 steps that we follow, and let us do that. If you remember, the first step is we need to rewrite this as sine x is equal to something. So I will collect all the terms with sine x on one side and then all the terms without sine x on the other side. Okay, so let's do that. So what I will do is I will take this one over there and then this will go that side. So I should have this. This is 5 sine x, and then we said this goes that side, so it is minus 3 sine x, and then the minus 3 comes to this side, so I have minus 4 plus 3. So you can see this 3 sine x went to the other side, that's why it's negative, and then this minus 3 went to the other side, that is why it is positive now. So here I have 5 sine x minus 3 sine x. I'm just counting how many sine x's do I have. If I have 5, then I subtract 3. I should have 2 of them left, so it's 2 sine x. And then here I have minus 4 plus 3. You should know this is equal to minus 1. So I'm almost there. I need to divide by 2 because I want sine x to be the subject of the formula. So I divide by 2, divide by 2. And I have sine x is equal to minus a half. So that is the first thing I have done. That is good. I can move on to the next thing. Okay, so the second step was to determine the quadrant that it lies in. So this is the quadrant. Okay, so this time I'm not going to draw the quadrants. I think we should be familiar with it by now, and we can already tell. Now here sine of x is negative. Then you can picture it in your mind. In what quadrants is sine negative? Sine is negative in the third quadrant, and it is also negative in the fourth quadrant. Okay, so sine is negative in the third quadrant and the fourth quadrant, so I'll need to keep that in mind after I work out my reference angle. So the next thing to do, work out the reference angle. So here I have a reference angle. So notice I'm writing down all the steps because all I have to do is remember the step and then follow it. Remember the step, follow it. Eventually I always get to the solution. So the only way to actually master this is practice. Do what I am doing. You can see me solving for sine x. Do that. You see me finding the quadrant. Do that. You see me finding the reference angle, also do that. Okay, so my reference angle is there, theta. Now we need to remember the question said we need theta, or we need x to be between 0 and 2 pi. Okay, so that is what we want. We want an angle between 0 and 2 pi. So what we do, okay, I think that's a little bit better. Okay, so for my reference angle, I look at what I have. I will just write sine x is equal to a half. So when I'm finding the reference angle, I ignore the sine. I'm just looking at the half so that I can get an angle that is in the first quadrant. So you ignore the sine when you're finding the reference angle. Then after you have found the reference angle, you just need to remember in what quadrant is it in. Okay, so here I need to do the opposite of sine. The opposite of sine is sine inverse. So I take sine inverse on both sides. Okay, now sine inverse and sine, those are inverse processes, or they're inverse functions. They cancel each other out. So I'm left with, here I call it theta because it's my reference angle. So theta is equal to, so here I should have written theta instead of x because that is not the solution. So pardon me. So theta over here, and then I go to my calculator. Okay, can you see it? So I say sine inverse of half Okay, look at that. The answer is 30. Now we need to remember that we are measuring in radians because it says we want an angle between 0 and 2 pi. Now this is measured in radians, so our reference angles and any angles we give should be in radians. So we said our angle from the calculator was 30, and 30 in radians is pi over 6. Okay, so I have my reference angle. Now I need to work out the solutions. Okay, so the solutions, we said we have an angle in the third quadrant, and then an angle in the fourth quadrant. Now we need to remember the definition of an angle in the third quadrant. An angle in the third quadrant, we define it as 180 plus theta, but here we're working with radians, so it is pi plus theta. And in the fourth quadrant, we define it as 2 pi minus theta. Okay, then we just need to substitute, remember what theta is. So we do that. So in the third quadrant, this will be pi plus pi over 6. So here you can do this on your calculator. Pi is 1, and then I add 1 over 6, and then your answer over there is 7 over 6. So I'll have 7 over 6 pi, and then here I will have 2 pi minus pi over 6. Okay, and again, if you do that on your calculator, you should have 11 pi over 6. So these are your two solutions. So we say x is equal to, just to conclude and formally answer the question, because the question says what is x equal to, and you're only done when you can say x is equal to this. So x is equals to 7 pi over 6, or x is equal to 11 pi over 6. And you can always test it, but when you test it, because these angles are in radians, change your calculator to radian mode, and then you will substitute it into the original equation, and then you will see that those answers are correct.